you want your face on the camera, you have to stand here. I know how many people are watching the YouTube. Yeah, whenever you want. I think now is probably the time is right now. Yeah. I don't think I see.
Excuse me, everyone. Can I say your attention for a moment? All right. Last lecture of the day. How are y'all feeling? Thank you. Thank you. So for those of you who don't know me, I'm Ethan Mao, and I'm running for first year rep on NSLAC Board of Directors, first year chair, and also EC class rep, but unfortunately none of you guys can vote for me. Unless of course you like drop out for the EC, but you know, I'm not encouraging you to do that. I'm just saying you could. Anyways, but you might be asking yourself, hey Ethan, isn't that kind of a lot of things to be running for? But hear me out. It would be really funny if a single first year had every single position they could were eligible for. So, additionally, instead of having multiple different people to chase after every time you have a problem, you just have me. So, you know, it works out for you. It makes it easier to, you know, come to me instead of coming to multiple people every time you have a problem. If you want all the boring stuff like my policy or platform, you can follow me on Instagram, Ethan for first year with for the number, or you can just find me after this and talk to me for whichever one you want. So, if all of you, so when voting opens this Wednesday at 9 a.m., make sure to vote for Ethan Mao for first year rep and first year chair to ensure that I never have free time ever again the rest of the school year. All right, thank you all for listening.
All right. Okay. So yeah, like my policy is like anyone asks like hi hello he's like too busy with election stuff. All right, so check out 538.com/Shanghai for the polling projections and stuff. All right, okay, yeah, anyone who wants to campaign, they can ask me, similarly to Praxis, of course. Okay, all right, so that's a collection of pirate jokes. I'll tell you like the programming pirate joke at the end of the lecture. So how many people started project one? All right, that's great. So most people, and that's what I want to see. I do want to go in detail over an example. If you've already done it, it might be not super interesting, but I think it's worthwhile to do. So someone tagged me. No, like we are live, right? So okay. No, we are live. So on this, oh, okay. All right. Okay. If no one complains, then I'm assuming that we are there. Well, no, nobody's saying no. I think I'm live streaming. So okay, can someone check if it's in the usual place? Okay. All right. Cool. All right. So let's go back to project one. So what we are doing there is we have three activities. So we have jumping, we have swimming, we have resting. So that's the example, not the actual project one. Hello. No quiz today, but other exciting events happening. So good for you for coming. For jumping, we are awarding 1 hedon per minute. For swimming, we're awarding 2 hedons per minute. And for the example from last Friday, that was it. So jumping 1, swimming 2, and then resting 0, and that's it. So here is what that looks like. So we have the function perform activity. And perform activity modifies the variable current hedons. And what it does is it just says, so I'll do it a little bit differently from last time. I'll say like hedons per minute is something. and it's gonna be 0 if it's not jumping or swimming, and it's gonna be 1 or 2 depending on whether it's jumping or swimming, right? So I'll say if activity is jumping, then I'll say hedons per minute is I believe it's is jumping 1, jumping is 1. Otherwise, maybe it's 2. So select all, copy, that's faster. And if it's anything else, then it's 0.
Professor.
Yes. All right. Cool. Thank you. Thanks for asking. So, all right. So now that we have hedons per minute, we can say, okay, so how many minutes? And I'll just say current hedons is equal to current hedons plus hedons per minute times duration. Make sense? So I'll fix this up in a second, but that's the basic thing, right? So I can here say current hedons is 0, and then I'll say perform activity, let's say jumping, and let's say I jump, what's a good time to jump for? 13 minutes. And then I'll rest for 7 just to make it round. And then I'll swim for 1 minute. So again, what I'm doing here is shift home, or on Mac, command shift left to select everything. And I use the arrows to copy and paste. So I'll swim for 1. And then the idea would be that jumping gives me 13 hedons. That gives me nothing. Yes, that sounds like someone I know. So yeah, I do, like many people, I have the thing where hearing my voice is extremely annoying. I do hope that you don't have this with me in particular, because otherwise you're in trouble. But okay. So swimming gives 1 minute. So 1 hedon. So that means that what I want is I want for current hedons to be 14. Sorry, swimming gives 2. So this is 2, so 15 actually. Okay, does this setting make sense to everyone? Yeah.
For the second call, I think we resting, right?
Yes, resting. Yes, thank you. Yeah, that's what I said. Thank you very much. Okay, does it now make sense to everyone? Yes.
I have a question.
Okay.
This person should probably belong to like a million like this before, but
Okay.
for the main thing, main equals main, like double quote and single quote is gonna make a difference.
So the question was, would double quotes or single quotes make difference here? So this is like slightly not on topic, but I will answer it anyway. So this and this are literally the same. So the only situation in which there is a difference is if you want for the quote to itself contain quote signs. So we'll do that later on, right? So if you want to say something, let's do it now. Why not? So you can say something like S is equal to single quotes, and then like artsies are smart and double quotes, right? So that's legit, right? So if you say this and then you print S, then you have artsies are smart, but in quotes, right? You couldn't do that with double quotes. So if you try to say artsies are smart in double quotes, then that's just a syntax error, not because it's like false or anything, but because the way Python reads it is it starts from the left and then it gets to here. So that's a valid string. And then it's like a string followed by just smart and then a quote. So that doesn't make sense to Python. So that's the situation where double quotes versus single quotes makes a difference. All right. So we'll have it on the slide at some point. Yes.
Oh, backslash quote.
Yeah, it would. Yeah. All right. Other questions about the cognitive abilities of arts and science students? Okay. Okay, so sorry. So back to the main event. Does what's going on there make sense to everyone? Questions? All right. So let me just fix this a little bit because this is slightly ugly. So here the function perform activity really does two things. It figures out the hedons per minute, and it also updates the global variable cur hedons. So in principle, this is fine, but I would like to separate things out as much as possible because doing things bit by bit is just better. So I might say this part, I'll just put in a different function. And that's what's happening in the project one handout, is that this is outsourced to a function whose job it is to just figure out what's the hedons per minute that they need, right? So I'll name it get hedons per minute here. And this is just going to be activity. And I just copied and pasted what used to be here up there. So now here, I'll just say hedons per minute is get hedons per minute activity. And now I have my separate perform activity that just uses get hedons per minute in order to figure out what it is. Oh, of course, you need to return hedons per minute. Over here, I could also directly say return instead of first setting hedons per minute and then just returning it. Yes.
To make hedons per minute global.
No. So the question was, should hedons per minute be global? And the answer is no. The way I communicate with get hedons per minute is I send it activity and I get hedons per minute back, and then I store it in this local variable over here. Okay. Questions about this? All right. So this is this. Let's just quickly test it. So in the project handout, you have a function that actually prints the value of current hedons. Let's make one. I'll say print current hedons. Doesn't take anything, just prints current hedons and then current hedons. So all it does is it just prints the value of this variable over here. Can call this function here. And it indeed prints 15, just like we wanted. So I added the columns, so now it's like current hedons is 15. Okay, make sense to everyone? Okay. So next, I want to make things a little bit more complicated. So I want to modify the rule. So the rule is now swimming is 2 hedons per minute unless there was a non-rest activity less than an hour ago. Okay. So that means that if I jump and then I swim right away without resting, then I don't get the hedons. So that means that this kind of setting is not exactly going to work anymore, because here get hedons per minute doesn't care at all about what time it is. It just takes in an activity and it returns hedons per minute, right? So at the very least, get hedons per minute needs to know what time it is right now. So what I mean by what time it is right now, well, like right now it's 13 minutes. And then here, right now it's 20 minutes. And then now it's 21 minutes. So at the very least, I need a clock. I also need to remember when was the last activity that was interesting. We'll get to that later. Let's make a clock. So if you think about it, just copying and pasting this so that I don't have to type it in again. So if you think about it, clock, if kind of how many minutes have elapsed, it's very much like the add function from the lab last week, right? So if you want to be able to say, I spent 15 minutes on an activity, then the clock is just whatever it used to be before plus 15, right? So I'll make a function, keep time, and it'll take duration as the argument. And all I need to do is to say clock is equal to clock plus duration. So if I start the clock at 0, and I say keep time, whatever, 12, and then keep time 8, then now the clock is 20. Does that make sense? So it's like literally the add function from lab 2. And it tells you what time it is in minutes since the beginning of the simulation. Yes? All right. So let's add a clock over here. So I'll name it like current minutes or something. And I need to here say that initially current minutes is 0. And then every time I perform the activity, so I update current hedons, and now I also need to update the time. So that's all it takes. So now I have a clock. Does that make sense? So what else do I need in order to follow the rule? Again, to remind you, the rule is 2 hedons per minute unless there was a non-rest activity less than an hour ago. So in order to know how many hedons to award, I need to know what time it is. And I also need to know when it was that the last non-rest activity has ended. Does that make sense? If I know that, I know what time it is. So I know it's 5:31, and I know the last non-rest activity, aka calculus, was an hour ago, right? So that wasn't even funny. Okay. So, okay. I guess it's just true. So, okay, all right. So what I want to do is I want to say end of the last non-rest activity. So initially, I'll just say last non-rest is like -1 or something. I'll say like -100 so that it's like a long time ago, right? So now every time I perform an activity, if it's not a resting activity, then I'll update my record or on when it was that the last non-rest activity happened, right? So I'll say if activity is not resting, last non-rest is what? So it used to be 20 minutes. I jumped for 5 minutes. When was the last non-rest activity? It used to be 20. I jumped for 5 minutes. Yes. 25, exactly. So what does it correspond to in the code? Yes, yeah. Yes.
Oh,
Yes, exactly, current minutes. Okay, I feel like at the current minute, not everyone understands this. So let's do an example. So I start with current minutes equals 0. I jump for 5 minutes. So now current minutes is now 5. And time of last non-rest activity is 5. Let's say I now rest for 2 minutes. So what's current minutes? 7. I heard 7 somewhere. Who does it make? If it doesn't make sense, let me know. Okay, does it make sense? Well, and nobody does anything. Yes.
So the time since the last long activity, that's a time since.
So this is time of last activity, right?
Without the time when you started the last long.
No, it's like when I ended it. Yeah. Okay, and because that's what I need to know is when it was that the last non-rest activity has ended. Yes. Well, I mean, like initially it's nothing. Initially, there wasn't any activity. And then let's say the first activity is jumping, and we did it for 5 minutes. So the end of the jumping session was 5. Then we rest for 2 minutes. So current minutes is 7. But then time of the end of the last non-rest activity is still 5. Yes.
5 minutes when you stop. Your jumping ended, but it started 5 minutes ago.
So this is time. This is the time, like when it was, like on the clock, when it was that the last activity ended. And the answer is at 0 hours 5 minutes. Does that make sense? Yeah.
Like, we're never resetting this clock, is what you're saying.
We are not resetting this clock. So here you could imagine, so this is the setting, right? So you could imagine that you do it once and then you reset everything and you do a new simulation. That's possible. Right? Yes. Well, it has to be something, right? And the reason I did it like that is because the rules say, which we haven't applied yet, that you need 60 minutes between the last activity and the current one. So if I make it so that the fake non-rest activity was 100 minutes ago, then it's as if it were like infinity minutes ago, because it's more than an hour. Does that make sense? Okay. All right. Other questions with me so far? All right. So now that we have last non-rest and we have the current time, we can go and fix this up, right? So here, if activity is swimming and also the current time minus the time of the last non-rest activity is greater than 60, then heathens per minute is 2. Right? So I can say and current time. So I don't have to do the parentheses, but I will just for clarity. So current time minus last non-rest. We call that last non-rest. So I'll just copy and paste it. Is greater than 60 or equal. Then heathens per minute is 2. Any other situation, heathens per minute is 0. Is that making sense? So let's do an example. So say again. Yeah, you can do. So here we're not calling a function, right? We're looking at the value of the variable current time, and we're looking at the value of the variable last non-rest. Yes. So it's only a condition for swimming, right? So swimming is 2 hedons per minute unless there was a non-rest activity less than an hour ago, in which case no. Okay, jumping is unconditionally one hedon per minute. You can jump for 10 hours and get 600 hedons, no problem. Okay, technically that's true about swimming as well. So it's about kind of when the last non-rest activity was. Yes.
Go back to the code.
Okay.
Where did you define the current time?
I defined current time over here. Oh, that's just a typo. Thank you. Okay. Is that making sense? Questions? All right. So there is one mistake in this code, which I will try to debug with you. Actually, does anyone see where? So I was kind of typing and then I saw that there is a mistake and then I decided to leave it out. So does anyone see a problem anywhere? So yeah. I mean, that used to be a problem, but now we consistently name it current minutes. Yeah. Yeah, that's excellent. So the answer was last non-rest over here. We're saying last non-rest equals current minutes, but that's the local last non-rest, right? So if we were to put a breakpoint over here, and then, so I'll just step over and I'll ask what's last non-rest. What is the answer going to be? So who says it's going to be 13? Trick question. It's not 13. So it's minus 100, right? The reason it's minus 100 is that even though over here we said last non-rest is equal to current minutes, which ordinarily would mean that it becomes 13, it's the local last non-rest that became 13, not the global last non-rest. So to fix it, we would say global last non-rest. So I'll stop the debugging. So the little crossover here. I'll run it again. Step over. What is last non-rest? Now it's 13. So obviously an easy mistake to make, right? So if there is a bug like that, this is the process that you would use, right? So you would say, what was it supposed to be? Oh, look, it's not what it's supposed to be. How do I fix it? Yes. There is only one last non. So it used to be that there was a local last non-rest and a global last non-rest. Now there is just one global last non-rest. Oh, it is. Like it used to be last non-rest equals to minus 100, and then it got to this line, and then last non-rest became 13. Okay. Other questions? Yes. Say it. Well, because we started the clock at 0 and then we spent 13 minutes jumping. All right. Yeah.
So the last non-rest is just recording when the last non-rest activity.
Exactly.
At what time?
Exactly. It's recording the time when the last non-rest activity happened. And the reason we need that is because we want to say what is current minutes minus the time when the last non-rest activity happened. And if it's smaller than 60, then we don't give 2 hedons per minute for swimming. I give 0. Okay. Other questions? All right. So that's good. So that's the clock. Okay, so we did all of that. So let me do a couple more slides just about the overall context of this. And then we'll do a little bit more coding, and then I'll tell you the pirate joke and we'll go home. And I know I promised the pirate joke a while ago. This time it's definitely going to happen. One thing I wanted to point out is just the overall concept of gamification. So you've all probably seen it in the handout. So I never technically defined it in lecture yet. So the idea is you turn interaction between the user and the computer into something that looks like a game. And the reason you would do it is you want to incentivize particular behaviors, right? So in project one, you imagine that you have this app that gives you stars for performing particular activities. And the idea might be that you want to incentivize exercise. And the way you do it is you imagine that the person implicitly tries to get as many hedons as possible. And you might try to figure out a strategy where you give out just the right stars at the right time so that the health points get maximized, right? So that's using gamification for good. So you can imagine like casinos or something where they have slot machines that are like gamification of life, I guess, where the goal is to separate the user or the customer from their money, right? So that might not be the best thing to do, but you could do it if it gives you enough hedons, okay? The other thing that I wanted to talk about is this idea of simulation. So what is it that we're doing in here in general? Like why, oops. No. No idea what happened. So why is it that we're doing this at all? And the answer is, it might be that we have a particular strategy for incentivizing behavior, but the behavior is too complex for us to be able to just write out a formula that's going to say, if you follow this strategy, then this is going to be the outcome. So instead, you do this simulation where you're saying, well, like if I try this, what is the result going to be? And that's actually used in practice. So for example, so I don't work there anymore, but and I didn't work on this project that much at all outside of just like talking to people, and even that not that much. But for example, you know, at the hospital, you have this problem of how many nurses do you want to hire on a permanent basis, and how many nurses do you want to hire as kind of a flex time workforce, where you want to be able to call someone up for a few hours if you are short on nurses. There's like other issues as well in Ontario, as you might know about that, but separately from that. So hiring someone full-time per hour is cheaper than hiring someone for just a few hours. On the other hand, if you hire someone full-time, then you pay them even when you don't need them, right? So what you want is some kind of, at least in terms of kind of spending as kind of the smallest amount of money possible, is you want to figure out some kind of combination of full-timers and people who you hire on a per hour basis in order to, you know, like not spend as spend the least amount of money possible. So how do you know how many to hire? Well, you don't. So there is variation in terms of how many beds are occupied, how many nurses you need. What you can do, though, is something like what we're doing in project one, where you have a computer program that has, you know, random inputs that are plausible. And then you see, well, like if I hire this many full-timers, then this is how much I'm going to be spending on average. And it works, of course, like not exactly the same way as project one does, but somewhat similar. Right. So there is a kind of real life application to this. Questions about this? I'll link to the paper if you want to read about it. I'm not going to We'll go into the details of the hospital budgeting more than that. All right. Is there anything interesting on Discord? Okay, there's 3 thumbs up. That's good. So, all right. So, let me fix up this code just a little bit. So in order not to overwhelm people, I wrote it as cur minutes equals cur minutes plus duration. So in Python, A equals A plus B is the same as A plus equals B. So I can rewrite this as current impedance plus equals impedance per minute and current minutes plus equals duration. Okay, yes.
For the actual project, do we need to have a separate function that determines our impedance per minute?
For the actual project, do you need to have a separate function? And the answer is yes, in fact, it's required, right? So like it's one of the sub questions asks you to write that function with a particular name. Yeah. So the question was, can we make last known rest something like -1,000 or something? And yes, like the answer is the only thing it cannot be a 0, because if it's 0, then what happens is current minutes minus last known rest initially is 0. So that means that you give 0 impedance per minute for swimming. Right? So anything, like you said, less than -60. Yeah. It's not. Maybe I took it out. Well, you can write it. Okay. Oh yeah. I think you're right. Yeah, I think I might have taken it out. Yeah. You can do whatever you. So the project handout is like a contract, right? So you need to do everything that it asks for, and you don't need to do any more than what it asks for. Okay. Other questions? Yeah.
Like we got like your contract, you also give us like a file that has all the functions.
That's right.
So like, are we allowed to add to functions?
Yeah. So the question was, can you add functions? Yeah. So just like I added get impedance per minute because it seems convenient to have it, you can add this particular function or any other function that you want. Okay. Other questions? Okay. So one more thing that I want to do here to just fix up the code is what we have in the handout as well. Instead of doing all of this, I again want to outsource it to a function whose job it is to initialize, meaning set the initial values of the global variables. So I'll name it initialize. And here it's going to have current impedance, and it's going to have current minutes, and it's going to have last known rest. And it's just going to do this. So I'm just cutting and pasting. And then here, I'll just say initialize. So one reason it's convenient is that now that I've done it, I can say initialize again, and I'm resetting the clock, resetting the impedance count, and I can do a new simulation. Right? So if I now jump for 20 minutes, I'll have like 20 impedance, and the clock would be 20 minutes. Make sense? Yeah. Yes, I mean, now I have to make them global. Before in the main block, I did not, because the main block is not in any function. Here, I'm saying initialize. So unless I set global current impedance, then it would be that line 48 sets the local current impedance to 0, not the global one. So before in the main block, I didn't have to say global current impedance. In fact, I couldn't. So in the function, I have to. Okay, yes.
Yeah, students permit changes for one of the.
Well, so heathens per minute is a local variable, right? So this is kind of like scratch work.
Oh, I meant like, sorry, so for running, I think it changes after like 10 minutes time.
Oh, yeah.
What would they?
You can do it. So the question was, can you use this? I mean, I guess the question was like the handout is different from the example in lecture. Yeah, that's usually the case. Yes, you have like you can use a function that's like that, but you have to figure out something for this that's not currently on the screen. Yes, in the back.
It says this is document that it gives $2 per minute for the first 10 minutes and then -2 after the first 10.
Yes.
If the user decides to run 15 minutes, it gives $2 for the first 10 minutes and then -2 for the next.
I'm sorry. So I'm gonna ask you to ask this on Piazza because I'm afraid of giving the wrong answer because I like mishear or something. So yeah, like I'll give the official answer on Piazza. Sorry about that. Okay. And like so like for the tricky parts, I also like go back to the text and just usually just quote the text back at you. Okay. Other questions? All right. I think the person in the back was stretching, or did you have a question? Probably just stretching. Okay. Oh, and now like this person is stretching as well. That's contagious. Okay. It's good. We can all stretch actually. So all right. Okay. We'll do a stretch break next time. It's like there's like 5 minutes left. So okay. So one last thing that I wanted. I did not touch anything. So one last thing that I wanted to say is testing. So like I said, so code that doesn't work 100% of the time just doesn't work. We do give you part marks for code that sometimes works in the same way that in Civ, if your bridge doesn't collapse right away, like if it's like in a course, it's kind of fine. You'll probably not get 0. In real life, if your bridge works for 5 minutes and then it doesn't, that might be a problem. When testing your code, what you want to think is, we are going to be testing your code separately with our secret test cases. So you want to be thinking about, okay, like what are examples where my code might not work? Does it work for those examples? How do I fix it? Right? So here you might be thinking, you know, like, should this be greater or equal than 60 or should it be 60? And then you're thinking, okay, like the question says, if it's more than an hour, then you can. If it's exactly an hour, then not, right? So 60 is kind of fine. But again, just kind of think about all the situations. Obviously, think about, you know, if you have an if-elif statement, you want to make cases where line 9 runs, and you want to make cases where line 11 runs, and you want to make cases where line 13 runs, right? So if your test examples do not cover all the possibilities in the code, well, probably the code doesn't work, right? Because if you don't test it, it probably doesn't work. Yes. No, so in Python, like there is, so the question was like error cases. So unless the handout specifically says what to do, you're not responsible for it. And that's because in Python, like, you know, like what if instead of a number, you give a string? Well, that's an error, but like there's no way to handle this uniformly. So whatever the handout says, that's what you're responsible for. Anything else, if the behavior is not specified, then you can do whatever you want, including crash. Again, like if the perform activity, like if activity is 42, it's not supposed to do anything in particular. So you can do whatever you want. Okay, yes.
how, what is the theory of wrestling between two activities? You're no longer trying to.
So again, questions about the handout on Piazza, please, because I might mishear and I don't want to like give incorrect answers. Sorry. Okay. All right. Pirate joke. There's 2 minutes left. I probably hyped it up more than what it's worth for. But anyway, just to remind you, like there's like pirate talk. So ye means you, and salty dog means sailor, or it might mean just friend. Matey also means friend. Ahoy means hello. So this is the screenshot from the Wikipedia for Talk Like a Pirate Day. So O'Reilly, one of the big kind of technical publisher, make the discount for the R programming language. R is one of the programming languages. R is also something that pirates say a lot, just the way I say like or so. All right. So anyways, in the high sea, pirates board a ship. And they say, give us all your treasure. And the captain says, sure, like I'll give you the treasure, but just before we give you the treasure and swim away, I have just like one question. We are in the high seas. There's nothing around us. However did you find us? I need to know. And the pirate captain says, well, matey, we made a geographical information system of all the trading routes and used machine learning to predict your routes and to predict your location. And that is how we found you. And the captain says, oh, wow, that's really impressive. Just one last question. What programming language did you use when you did this question? And the pirate captain says, R, matey. All right, up here.